Okay, we're going to finish convolution, but before we move on to the last problems section here, uh, I had when I did my sketch of this, 10/3 is the right height. Everything was correct. It's just my scale over when I did the drawing was wrong. And you'll notice how it. So I just readjusted the sketch, and you can see how it just all kind of fits. The slope here matches into the slope there. So this looks a little bit better. So here that is all corrected. So we're going to go to the last basic problem here, and we're going to actually do it twice. So here we have something that's almost realistic. So I have, here's my input. It's e to the minus 2t, and my impulse response is a step. All right, not terribly realistic, but if we were to flip these, it would be. And we'll talk about that in a minute. Okay, so here's the impulse response. It gets hit by an impulse, and doink, it goes up. Now, if so notice that it's going up and it's staying up. So that's actually not a stable system. So let's look at here. So here we said our input's going to be this e to the minus 2t. So it's kind of steps up and then it's decaying like so. If I look at this, notice e to the minus 2t, the minus 2. If I take that 2 and flip it, 1/2 would be the time constant. 4 time constants is settling time, that's 2 seconds. And this is the 2% settling time. Recall that we call 4 time constants or settling time because at that point, 98% of our dynamics have been attenuated out. And so that's why I show it right here at 2 basically being done. There'd still be a little left to go, but for my art, it's appropriate. So I want to take this and apply it to this basically step impulse response. And let's see what this response would look like. Okay, so what that means, let's just do this carefully here. So if this is the input, I want to take it, flip it, slide it through. All right, so if you look at this input, it has sort of one corner where it slides through, and then it's just going back in time, dying out. All right, and I have one corner to this. All right, so basically this model can go through for all time and just do its thing. Okay, so since I only have one corner to deal with, when this one and that one collide, it takes only one integral. All right, so I look at, here's the picture that I drew of my situation. So we have, to do a flip, everywhere I see a t, I put in t minus tau. There's that, and that corresponds to that. I take this, flip it forward to the time t I want. So here's t minus tau in place of the tau. That's all we have to do. Now the impulse response everywhere when we multiply these together is just a 1. Okay, put a 1 up here. All right, so now I have an integral from 0 to t, e to the minus 2t minus tau, that's this piece, and then the impulse response is 1. So integrate it. You get that, boom, 1/2, 1 minus e to the minus 2t. I want to do this one more time and create what it would be a realistic system. Now I'll note if you were to plot this out, okay, time constant is 1/2. Okay, this would correspond to a real root at minus 2. We take that, take the absolute value of the inverse, you get time constants 1/2. 4 time constants is 2 seconds. Okay, here's the 1/2, and boom, here's our response. So now we're going to do it again. All right, so when I do this the second time, I'm now going to let S of tau, which was last time was the impulse response, now it's the input. It says flip the light switch on. It's realistic, and we'll just leave it on for forever. All right, because we don't know when we're going to turn it off. All right, and Here is now our impulse response. So that would say if I gave this a kick, it goes up to 1 and it dies off. That's realistic for a first order system, completely conceivable. All right, so now this is the input, so I flip it and slide it through. I still have one corner here, one corner there, so I only need one equation. So here is that unit step input. I slide it forward to t, and it's just going back forever in time. All right, and here is e to the minus 2t sliding down like so. All right, so I multiply this by this and integrate. So I'm going from 0 to t, doesn't matter what t is, this thing just keeps on going. All right, 1, that's the step input, e to the minus 2t, that's the impulse response. Get the same answer. And you'll notice this and that match. Guess what? This is always true. So it turns out you can flip and slide the impulse response, or you can flip and slide the input if something is mathematically easier to deal with. Doesn't matter which one you do. However, the idea of flipping the input and sliding it, that is actually how in the real world, in the physical world, things actually respond. And so here we have, but this is an interesting mathematical notion. You can convolve an input with the impulse response, or you can flip them around. It doesn't matter. You get the same answer either way. And with that, we are done with convolution by hand with integration. We're going to see convolution again here very soon, but in a different, more subtle way. And you'll like it. Or at least I hope so. We'll talk to you soon.